And good morning and welcome to Apex here in Anaheim, California. The first of our panel debates today is on defense electronics and next-gen technologies. As defense systems become more advanced, the role of cutting-edge electronics is critical, enhancing security, resilience, and operational effectiveness. This panel is going to explore some of the latest innovations in the manufacturing of defense electronics. I'm delighted to be joined by a very distinguished panel. To my extreme left, we have Will Oliver from Federal Electronics. Next to him, we have Gary Walker from Javad EMS. Then we have Graham Hinshaw, Michael Hinshaw, sorry, from Green Circuits. And next to me, we have Tae Kwa Lung from Naprotec. So, welcome, gentlemen. Thank you for coming in today. And I'll get started really with my very first question, which is what are the most game-changing advancements in defense electronics from a manufacturing perspective? So let's start with you on the end, Will.
Well, I probably ought to qualify that I'm not an engineer, but I am customer-facing vice president of business development, and there's a lot of things that have changed that come out in initial conversations with customers. I go back 8 or 10 years where we were, I would be sitting in rooms where, some of the requirements were SPI, 3D AOI, things of that nature, and all of that is absolutely required for defense-related manufacturing. But now with AI, quite honestly, I think the biggest change that you see in defense, and I'll probably repeat this on some of the other questions, is, to me, defense design, product, weapons, things of that nature, has adopted a Silicon Valley model. It's no longer a decade of, design, development, and deployment. It is, it's exponentially speeding up.
Yep.
It's not to a consumer electronics level, but that's the direction that we're headed. So you've got to keep up with all of that technology, because if you want to service the defense industry, aerospace, you simply have to have all these capabilities in-house.
Yeah, absolutely.
Yeah.
I mean, Gary, back in the day, defense electronics, a lot of it was still done using, tin lead manufacturing. There was very little SMT, or lead-free in defense electronics, because they wanted the reliability. Obviously, over the years, you haven't been able to get access to some of the components you need to be able to build the boards, so you've had to sort of start bringing in, some lead-free. But how are you finding it in the factory just now? I mean, are you using a lot of? Are you still using a lot of, lead-free or tin lead?
For the military aerospace customers, yeah, it's a mixture. So it's leaded solder. I mean, it's all leaded solder, solder paste, right, solder machines. As far as the components go, they're mostly lead-free. I mean, there's not a market out there for a lot of leaded components. So we're running hybrid assembly processes for them. So that's basically what.
That's the way you have to get around it, really.
Yeah.
Michael, any new technologies that you can think of? What's the latest advancements that you've got?
Well, I think what we're seeing is for defense, it has to be built, and all the components need to come from onshore, effectively. And so you're limited in what you can go out and acquire. I think there's a mindset that my colleague mentioned is right around speed and agility, finding things that are rapidly replaceable. I think in the global conflicts we've seen over the last couple of years, one of the mindsets is replaceability, defensive, fast-moving, and getting capabilities in the hands of our service men and women.
Right.
And so that dictates that we have to use what we have available. And I think that's a mindset, and it's been written about quite a bit recently.
Well, I mean, essentially, defence procurement is very much about replenishment, isn't it? It's once it's used in the field, right, and you're replenishing the stock, essentially.
Absolutely, yeah.
Say, Kwa Lung, you got any thoughts on
Sure. Yeah. So I think I don't think it's new. I think it's been a continuing thing, right? Swap is obviously a big for the military side. Things are getting smaller. If you look at some of the wearables and the millimeter wave, and it's just there's a drive to smaller and smaller components and sizes and basically places where you can put your electronics, right? So even on the legacy platforms, they're adding more and more capability, and with that, they have to miniaturize everything. So really, I think for us on the, at least in my business on the assembly side, we're looking basically at the state of the art currently, 0.3 millimeter for basically a placement, which is the current state of the art, but things are advancing. So when you look at 5G, when you look at millimeter wave technology, they're going down to 0.5 millimeters.
Yeah.
So we have to be cognizant of that. When the customers come to the requirements, we have to make a business decision to say, hey, is this a CapEx we have to go buy? So those are definitely some of the things we're looking at, and that's on just the PCBA side. And you look at the RF side, got ion beam milling for thin film circuits, right? And they're now looking at even finer than that. Mm-hmm. So those are just be aware of what your customer requirements are and whether or not you have the CapEx equipment to support it. So something to monitor, something to look at from a business perspective.
Yeah, absolutely. Well, they're obviously trying to pack more functionality into the systems, and there is also a weight factor as well for soldiers that are carrying things in the field. You don't want to have too much weight, and the communications have changed completely over the last decade as well. That's another thing.
And I would add to what you've commented on. There's a higher demand for higher levels of certification, cybersecurity, J standard, expectations that continue to be tightened,
right,
to be more effective in producing components for the defense industry.
We're going to come on to the CMMC stuff of that later on today, but I know exactly it is getting stricter and stricter, and it needs to do. It's there for a reason, but we'll come on to that in a minute. The face of modern warfare has changed a lot, and I think in Ukraine it showed. I think really the drone system has really changed the game. So as these unmanned systems continue to evolve, what new manufacturing challenges do drones and autonomous platforms present? Back to you, Will.
Well, I mean, if you look at drones and I guess they've been out, a decade or two now. The traditional defense drone is really the size of a small plane.
Yeah.
Right. And a lot of people probably didn't realize that. So now we're moving to almost a disposable model where you see more of at least from a visual standpoint, it looks like a consumer model. They're small. Mm-hmm. They are deployed in swarms. And so because it's somewhat becoming a disposable model, they're full of technology, all full of electronics, but it's higher volume.
Yes.
This is something that can be carried by the warfighter in theater. Mm-hmm. So much smaller, but still has all the same technology.
Yes.
Yep.
Yes. That's right. A lot more technology getting packed into them, but I mean, so they come in different sizes, though. Of course, I mean, it depends if it's carrying ordnance, then it's a bigger unit. But if it's something that's being used for visual reconnaissance, then it doesn't need to be big, how are you finding? What sort of challenges are you finding? Are you doing manufacturing any drones?
Yeah, so we actually work on one particular program for a drone. So it's, in this case, I know a lot of drones are going, they're the single use. They go out, they never come back. The drone program we're working on is actually launched. It's like a launched from a person, but it actually will go out, perform a mission, target something, and then actually come back. So you look at companies like Anduril, they're one, they have a Roadrunner, they have a few other drones that actually are coming up, going out, doing something, and then coming back to position it. So not all drones are being disposed of now. They're trying to get more use out of them. I think most people see the Ukrainian war, and they see the quadcopter drones that are going out, the FPV drones. Mm-hmm. The drones that we're seeing and knowing of are, a much higher extent. You look at the marine drones that are going out there now. There's a company in Austin that's making an American version of the Sea Baby, a much better version of the Sea Baby, a Ukrainian Sea Baby. You look at General Atomics, you look at Anduril, they're both in the CCA, the Collaborative Combat Aircraft, so they're going to go out in a swarm with an F-35. So they're looking at taking the human element as much as they can out of warfare.
Right.
And the more they do that,
Right.
the more effective it will be.
Yes. Well, I guess they can take greater risks, if it doesn't have a human inside, I guess, Okay. Are you involved in actually designing the drones, or are you just building them?
We don't do the designs necessarily. We can be supported. We have
Right.
ITAR design capabilities, but by and large, the defense companies want to design their own and keep that IP close at hand.
Right.
So we'll support perhaps on production, but typically
Yeah.
not design.
So you're really only concerned with the electronics rather than the flight,
Yeah, we're focusing on the assembly.
Yeah.
And to tag on to what my colleague just said, I think there's also a move to a lot more communication, individual point-to-point level communication. That's why we're seeing a lot more growth in space applications to be able to communicate across broad spectrums,
Right.
And a lot more defensive. And I think early stages of recent conflicts, there were no good real solutions to defending against drone attacks and defending against
Right.
this kind of technology, and that's changing
Yes,
quite a bit.
Yes. Yeah, I think the same applies in space. You've got a lot of things going up into low orbit now, in space. But my concern is that a lot of them are, they're undefended, and they're fairly dumb satellites, But that's another question. Okay. I think we've answered that one, so we'll move on to the next one and start with you, Teiko, which is are material shortages and restrictions on critical materials from China proving a challenge, or are you able to source them from alternative sources?
Yeah, I think it really depends on the volume issue, right? Obviously, if you have a huge volume shortage like we saw on the chip side, that's going to disrupt the industry. So you have to have a strategic supply chain approach. So, on the EMS side, we obviously use a lot of the large distributors, which can actually buffer some of that because they'll buy some of the material up front and they can hold it in stock. And so they can also look at some of the market trends. So, going with the large distributors do buffet some of that issue. At the same time, we're looking at other suppliers as well for sourcing material. It was mentioned earlier, obviously on the defense side, everything's got to be U.S. based, right? So we're not, we're not relying on the Chinese based kind of technologies and material. So I think, what we're doing on the government side also, which is trying to bring everything to domestic shores, to do everything here, is helping. But to really wing ourselves off of foreign technologies, it's still an ongoing issue. But strategic sourcing, looking at multiple suppliers, looking at multiple distributors, is the way to try to offset some of that.
Absolutely. I think you all need to have second and third level sourcing, for materials. That makes perfectly sense. But coming back to having an end-to-end supply chain here in the United States, there's still, as you said, a lot of work to do on that because the government's poured a lot of money into the CHIPS Act and these guys, but they're the guys that've got lots of money. And the PCB boys at the other end, who need the support, are not really getting it. We just lost the last copper rolling mill in the United States 3 months ago. It closed.
You're absolutely right. I think there's a growing recognition and there's a growing effort in the industry. IPC, our industry association, spent a lot of time in Washington trying to get and educate more than anything else our legislative branch in particular about the benefits of the CHIPS Act, but how we need to get beyond that into boards, assembly, training, to talent development, and then all the components that go with it.
Yeah, I do want to add on to the CHIPS Act. I think one of the issues that we need to be aware of is a lot of these things become just butts and seats, right? So is it really enabling what we need to happen, or are we just creating jobs so that we can check a box on the government side? So I think as an industry, we need to kind of continue to push, how we actually get that base here in the U.S. It's not just about technology, it's all about education. It's all about starting early in the cycle, like training our kids that this is important to move into that industry versus, hey, let's just all become investment bankers and do that. So I think it's a huge issue that the CHIPS Act likely won't solve on its own. Right. It's really infrastructural. How do we bring that service back that we essentially pushed overseas over many decades? So that's something that we really be cognizant about. Yeah.
Yeah, absolutely. I totally agree. But I mean, how do you attract companies back that make the basic components? Component manufacturing companies. You're still going to buy your resistors and transistors and things like that, probably from a Chinese source. It's very difficult.
It's an equation that none of us are capable of solving at this point. That's the billion-dollar question, though, that if we can answer it. I think one of the things that people don't talk about a lot is, as we bring some of these capabilities back in the U.S., and depending upon what the government will do in terms of requirements of where you're getting your supply chain, it will strain the North American or U.S. Capacity as requirements tighten. So that needs to be recognized as well.
Yeah, you need to get ahead of that.
Yeah, absolutely.
Yeah. Okay. Right. So, Gary, you anything to add on the materials shortages side? We pretty much covered
what
that.
everyone said is pretty accurate. I mean, for us.
Okay. All right. So the other thing I want to touch on is the fact that the timeline for everything, as Will alluded to at the beginning, is getting shorter. And certainly on the consumer side, it's getting really short. But even on the defense side, how are you managing to deal with that? I mean, it must be quite a demand on you. Are you finding that you're having to spend less time testing things? I mean, how do you deal with things that need to get to market quicker?
So the defense industry itself is moving much faster. So there's been a push to somewhat commercialize, to go out to the commercial market, the commercial off-the-shelf market, to try to bring some of that in to move programs along faster. Right. You look at some of the new guys who are entering the defense space; they're moving at a much faster speed than the traditional large guys. So I think that in itself is pushing them as well. So things are moving faster. They're designing in off-the-shelf type products that they know can work, that can meet their standards, and it's not going through the traditional, and not in all cases, but in many cases, the years and years and years of trying to test these out. They're getting them, they're putting them in play, and they're testing them out, and if they work, then they move forward with them fairly quickly.
Yeah, it's like what I was saying earlier about the lead-free stuff. I mean, initially, the military didn't want to use lead-free because they didn't know about the long-term reliability of it, quite frankly. It wasn't tested, but lead-free's been with us now for almost 20 years, so it's pretty tested now.
To Gary's point, I was at AUSA in Washington in October, I believe is when that was, and I forgive me, I forget the officer's name, but he was a high-ranking officer in obviously in the Army, and he spoke for an hour on this exact issue. That not only it is, I call it the Silicon Valley model. It's spinning faster and faster, but there has to be the military, DoD, has to embrace this model because we will eventually fall behind if we don't.
Right.
Yeah.
So they have there's a unit called the DIU, Defense Innovation Unit, and it's actually the guy that heads it up is out of the Bay Area. That's where they're driving this to try to move to
more Silicon
to
Valley
the non-traditional military guys to try to move things much faster. And they're funding companies. They're trying to initiate them to build things, to collect their products, to bring them in and put things together much faster than the larger guys are doing.
Yeah. Well, I've seen that work successfully before. I had a colleague, Joe Felstein, actually, who joined a number of years ago, joined a company called Pacific Coast Consultants, and they got a DoD project to improve the communications in the warfighters' uniforms. and the envisaged cables coming down from the helmet through the uniform, etc. He said we came in ahead of budget, and we gave them Bluetooth, communications for the soldiers. We gave them guns that could shoot round corners. He says the level of technology. That's because they outsourced it to be a Silicon Valley project, rather than using the traditional, Defense Department design.
That's absolutely true. We do a lot of quick turn. That's our foundational business, and so what we see now is real-time interaction.
Right.
We feedback. We have customers in on the floor as we're running. We can make real-time decisions and adjustments.
Right.
And that's just the mindset model we used, and I think the defense sector is taking that on.
Yeah.
Just to add on to what Michael's saying, I think to help actually accelerate some of this MPA process into defense, I think if you're a provider of services, PCBA services, RF assembly services, you want to be actually tackling some of those commercial applications as well, because their MPI process is much shorter, as we've discussed. I think the good news is while we have government agencies looking at how to accelerate this, the acquisition model is still not completely fixed, right? It still takes a long time. So even if you're looking at quick turn on I'll say defense A&D type timeline, it's still a lot longer than a commercial timeline that could be 4 days.
Yeah.
Right. So I think if you can do both the commercial side, then you kind of know how you can support the defense side. It's a matter of really how quickly can they turn the acquisition model around to really move into that Silicon Valley mode.
Right. Okay. Okay, I want to get on to our last topic before I give a bit of time to that, and that, of course, is the incoming and CMMC regulations. Absolutely necessary to have, strict controls of communications and electronics within the defence factories, but it's a very expensive and time-consuming process, and a lot of companies have ended up having to hire somebody specifically on staff just to deal with it. What's been your experience of it, Will?
Well, for sure, this is not an area of expertise for me, but a lot of the same things were happening in the early days of NIST, and so I think you see this repeating itself. Hopefully, lessons will be learned from the early NIST days, but it's. I think, and maybe these answers already, but is this going to be where you can self-certify? I don't think we know that yet. So does that mean?
I thought you were going to have to get an audit. Do you not have
well,
to
you're going to have
a government
to get an audit, right?
Yeah.
But who's going to do the audits? Are there enough companies out there that are going to be able to provide that? What are the flow downs? Right? Is it CMMC for just us, or are we going to have a supply chain that 100% complies to it as well? So there's a lot of questions that still need to be answered. But to your point, for the companies that are going to deal in the high reliability aerospace and defense, it's a necessity, and more than likely they're going to have somebody on staff that will be, dealing with it and be the resident expert, if you will.
Right.
Yeah.
Okay. Gary?
Yeah, so I would agree on that. For us, we're pretty comfortable with it. Most of the defense companies we work with, after you engage with them and they're interested in working with you, the next group you work with is their IT and cybersecurity department, and they won't even provide any information until you pass that. So it's kind of a strenuous process to go through and make sure that you have everything in line. So we've done that enough where we have a comfort level. For us, we've already engaged with some companies that could do the audit and do the certification and that.
Right.
It's really now just a question of writing the check. I mean, it's not that easy, but at the end of the day, it's very expensive. And for us right now, we would just prefer, if we don't have to, we self-audit, we provide them everything we need. If and when we have to write the check and be certified, then we will move down that road.
Yeah. Okay.
I think to add on to the writing the check and the expense of this, the defense industry has long embraced small companies, and there's a possibility that this is going to put too much pressure on them to move to the CMMC. It may not be affordable to them.
I agree.
And so that will potentially eliminate a lot of the traditional supply chain.
Yeah.
Not just in electronics, maybe a little bit more so on the mechanical side of things. But that's something that we're going to face as well.
Right. Yeah. And it's adding a lot of cost. And, the government's focus, or the current administration's focus, is in reducing cost. Actually, in fact, and they're even, they're looking at the Defence Department as well to see if they can reduce cost. Interesting quandary there. Anything to add on it?
Sure. Yeah. So just to add on that, I think the complexity with CMMC is really navigating that framework of requirements, right? Whether you're going for level 1, level 2, or level 3 certification. The issue really is safeguarding for smaller companies. I would say safeguarding the CUI, right? Do you have the IT infrastructure in place to do that? Not just when you're passing information to your customer, but really internally in handling that information. So having somebody who is an expert on staff who can work with that, who can also work with the third-party assessors to tease out the issues, I think is going to be key.
Yeah.
I agree with Tay on this, and I think there's we've found, I think you have to be agile in how you think about it and where you can isolate things. The smaller you are, the more flexibility you have in getting control and where you have it. Training programs, we have consistent training programs. We are constantly trying to trap our employees making a mistake, and they've done a spectacular job. They're learning from it, so it's.
Yeah, but it adds another layer onto every new hire that you bring in. You've got to get them up to speed with it too. Yeah.
It's coming.
It's coming. Yeah, you're not going to stop it. That's for sure. But anyway, well, gentlemen, a great discussion today. I want to thank you all very much for taking part. Thank you very much, Will, Oliver, Gary Walker, Michael Hinshaw, and of course Tay Kwa Lung. And thank you to our audience for watching today.
Synchro. Join the revolution. Non-stop selective soldering. Increase UPH. Reduce maintenance. Small footprint. Contact us today.